Motors are the driving force in automation equipment design. But there are many different types of motors for multiple applications within the plant. There are times engineers need power, speed, and precision. At other times, control distance or direction are more important, allowing for more cost-efficient solutions. Matching the right motor for the right application can improve operational efficiency, help manage energy consumption, and drive your success. In fact, operational costs over a motor's entire life cycle will make up the majority of its total expense. To help illustrate this, let's take a look at a typical motor choice: servo motors versus stepper motors. A stepper motor operates on a signal, typically sent as a step and direction command to the motor's drive. These commands dictate distance moved and velocity. Though some stepper motors operate in closed-loop systems, most operate as an open-loop system, meaning the control signal only comes into the unit. In a traditional servo system, the controller sends commands to the motor's drive via pulse and direction, or via an analog command related to position, speed, or torque. Once the drive sends appropriate current to each phase of the motor, built-in encoders record real-time positional data, which is fed back to the controller. Servos are considered closed-loop motors, which allow the controller to make adjustments as needed. While a servo motor may offer higher torque and faster speed, there are still many cases where a stepper might be a better fit. For instance, in some applications, using a stepper can help your bottom line, as it requires less routine and emergency maintenance. So, where do you start when it's time to evaluate your needs? In general, it's best to start with 3 basic questions. How many cycles per minute does the motor need to make? How much torque is needed? What is the peak speed required? These questions are important as they help you look at more than just the overall power output, which in some cases can be misleading. For instance, while the overall power output of a motor can be calculated by multiplying speed, torque, and a constant, 2 motors with similar power ratings can operate differently. Once you understand your precise torque and speed needs, it is a lot easier to make an informed choice when it comes to choosing between servo and stepper motors.